All right, here we go. Let's get some facts at you. All right, not that we needed more, but you were forewarned at the beginning of this unit. All right, here we go. Fact number one about circles. Fact number one about circles today. Everyone, please call this circle O. Circle O. And as I walk around, please draw central angle AOB. Draw yourself a central angle right now and call it AOB for me. Good work, good work. Comes from the center, right? AOB. Draw yourself a second central angle in the same diagram. Call it angle BOC, and at your best ability, make it look congruent to the first one. So make a second central angle, name it BOC, and kind of make it look congruent to AOB. I'm not a big fan of that. How about this? There we go. What did I say? BOC? Come on, one job. I know it's been a while. It's been a long time. How do I show they're congruent? What can I mark on the diagram there, Cal? Arc marks. Yep, so put arc marks there for me. So here's your first fact today, everyone. If the central angles are congruent, so are the arcs. If two central angles are congruent to each other, so are their arcs. So underneath number one, let's write this. If angle AOB is congruent to angle BOC, so two central angles are congruent, then the arcs are congruent. And you remember the symbol for arc, the little arc mark there? Then AB is congruent to BC. And now, I don't know, did we go over how to mark arcs congruent? No? Just put a little hash mark like you would do the segments. That's fine. Yep. All right. So if the central angles are congruent, so are the arcs. And number two says the reverse. If we ever have two arcs that are congruent, so are the central angles. We don't need to write anything underneath. We okay on the first one? Central angles equal, so are the arcs, and vice versa. All right, good deal. Second diagram, theorem 2. Again, circle O for me. Can you guys please draw in chord AB? Anywhere you want. Chord AB. Chord AB. And then do a second chord CD anywhere else in the circle, but kind of make it look congruent to AB. All right, so you have two chords, AB and CD, and they're congruent to each other. And let's mark them congruent with our hash marks. Here's your second theorem. If the chords are congruent, so are the arcs. If the chords are congruent, so are their arcs. So for us, if chord AB is congruent to chord CD, then their arcs, AB and CD, are congruent. There you go. So central angles are equal, so are the arcs. Chords are congruent, so are the arcs. And number 2 says just the reverse. If you have the arcs instead, the chords are equal. Anything before I go in a different direction on these first two? Yep, yeah.
So just to clarify, when you write the chords, they're just like lines, right?
They're just, all chords are line segments. Line segments, that's all they are. Okay. I don't need a fancy symbol for chords. It's just a line segment, but it happens to be inside a circle instead. Okay. All right. So for the third one here, Let's go in a different direction.
Sorry.
It's fine. Chords equidistant from the center. Whoa, 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 whoa. How about that one? That vocabulary term from back in the day. If you have two chords, they're the same distance from the center, those chords are equal. Done. Everyone see two chords up in your diagram? I didn't want you to draw this one. D, E, and C, B. How far away from the center are they? 8 units. They're both the same distance away, so that makes the chords congruent. All right? Two chords are always equal if they're the same distance from the center. All good? I don't need to write anything here. It's all there for you. All right? Chords that are the same distance from the center are always going to be the same measure. All good, because now I get fired up on this next one. This one's the huge one for today. Huge one. All right, circle O again. Go ahead, circle O. Then draw in diameter AB. After we go for the high score. Go draw in diameter AB. So you guys hopefully remember diameter's got to go through the center. Ready? Now I want a chord CD, but listen carefully. The chord has to be perpendicular to the diameter, which means it forms a what? Right angle. So when you draw your chord CD, it should form a right angle with your diameter. And to show it's perpendicular, let's throw the right angle symbol up there. And last thing, I'd like you to put a point of intersection where the diameter and the chord meet. So E, F, G, whatever. Wherever your chord and diameter meet, can you please put a point at their intersection? All right, so what's the magic that happens when you are given this? If you have a diameter that's perpendicular to a chord, I'm going to reintroduce a new vocabulary term, or an old vocabulary term. Diameter, perpendicular to a chord, bisects the chord. Not the diameter, bisects the chord. What was bisect mean again back in the day? Into two equal parts. So which are the equal parts up here? Or for my diagram anyway. It might be different for yours. CE congruent to ED. Correct. So I'm not going to have you write anything, but at least mark it on your diagram. CE congruent to ED. That's only if the diameter is perpendicular to the chord, cuts the chord into two equal parts. Stop right there, though. Here's the thing, though. In a diagram, you may not be given the full diameter. Watch, you may be given this instead. You let me know if this is still okay. What if I just give you that perpendicular to it? Is that still okay? Yes, it is. That's still okay. As long as it's part of a diameter that's perpendicular. Everyone see this right here? This theorem still applies. Even if I just give you this, I can't do this, but let me cover up this part right here like that's not there. So everyone see this little piece right here? As long as that's perpendicular, it still applies. All good? As long as the things come going from the center, this theorem applies. Because I highly doubt most times I'll give you a full diameter. As long as it's coming from the center and perpendicular to the chord, you're good to go. Good to go. All right, enough talking about these theorems. It's your time now. Do not get nervous. This is not proofs. Okay, these are not proofs. You don't see prove anywhere. Here's what I want to do. I'm going to give you a true fact. And then I'm going to go around the room and you tell me as many true facts as you can get from that. All right, based on these theorems we just talked about. So number one, I'm telling you those two arcs are congruent. PR and SU are congruent to each other. The arcs. Arc PR is congruent to arc SU. If that is the case, what else is congruent? Again, not a proof. I just want to list out everything that's true right now. So think about the 4 facts we just went over. If arc PR and arc SU are congruent, name me something else that must be congruent, and I'll work with you on the reasons. 8, what else is true, do you think?
PR and SU.
What do you mean? Because there's a lot of PR.
Segments.
Go, you're better than that. Thank you. Chord. Everyone agree? Chord. The chords PR is congruent to chord SU. That is true. That is true. Good job, Cal. The question is why? It's a theorem we just went over. Everyone ready? What was given to you? Congruent. So that's ready? Congruent arcs. That was given to us. Oh, we'll remember these days. I'm going to let you use the arrow. Implies. What are congruent, Calvin? V?
Chords.
Congruent chords. And I know you're wondering, why are we doing it like this? Because you're going to actually do official proofs tomorrow. They're coming back tomorrow. Finally. Oh, I'm not satisfied, though. What else are congruent? Come on. There's something else in this diagram that are congruent. Molly. QN? Yeah, you're talking about the angles, or? Yeah. Okay, yeah. I'm just going to say angle Q and T. Everyone good? Q is congruent to T. Also true. Ooh, why? It's a theorem we went over today. Again, what are you given? What was given? Congruent arcs imply, what did Molly just give us? Congruent, what are angles Q and T? Name them. Central angles. There you go. There's another theorem we could use. Great job. Both of you there. Good job. I got one more that I don't expect anybody to get because I haven't gone over it. Ready? But maybe you can tell me why. Because this one will be used a lot. PQ is congruent to QR in that one circle. Facts. I just want to know why. Why am I okay saying PQ and QR are good in that first circle? Scott, what do you think? What are they?
Is it because all radians are the same?
Radians?
Or not radians. Radius.
Radiuses?
Radius.
Radii. Radii. That sounds weird, but it's radii. Yes. Hey, if you have a circle and I draw a radius in and another one and another one and another one, they're all congruent. Okay? So the reason here, and we're going to use this one a lot, in a circle, all, how do you think you spell that funky word? R-A-D-I. Double I's, correct. How about that? It's gnarly looking at that one. In a circle, all radii are congruent. We're going to use that a ton. Good job, everyone. Good job. All right, next up, same thing. I'll give you BC is congruent to KL. What can you come up with on your own? BC congruent to KL. What else must be true? If those two are congruent, what else are congruent up here? 17?
Arc BC is congruent to arc KL.
There you go. Because arc BC congruent to arc KL. True. How do you start this reason out? What did I give you here? Via, what did I give you? Good. So tell me, congruent chords. Good. Implies congruent arcs. We're picking it up here, I think. Keep going. I want one more at least. Don't tell me. I don't want the radii either. I know that's true. We just said the arcs were congruent. Keep going. Oh, that must mean now what else is congruent? The chords went to the arcs, and now the arcs will tell me what else are congruent up here. 12? Good. Angle A congruent to angle J. What's going to be a reason here? Be careful. Be careful what you say here. These angles aren't equal because the chords were equal. So I'm not going to start out with congruent chords because that's not the reason the central angles were equal. Well, how did I know the central angles were equal? Because I had congruent, not chords, but arcs. So congruent arcs from number 1 imply I have congruent central angles. There you go. And yes, I know we could say the radii are equal, but we went over that already. Whew. Anything here? Because now I want to put numbers on the diagram and use these facts. Let's put some numbers on these bad boys. All right, need your help. Find x. And then we're going to write the theorem we used. Got to find x somehow. What is 8, by the way? What did I label as 8? What's that called? That's a chord, right?
Yeah.
Anybody see one of the theorems being applied here to that chord? Hey, I told you, don't look for a full diameter. Look, see this piece coming from the center? Good enough. Because it's perpendicular, what's happening to my chord? Getting cut in half. Everyone see what I was talking about? Because it's coming from the center, perpendicular to chord, it's being cut in half. So what each piece would be? 4 and 4? Oh, you're not out of the woods yet. How do I find x? Come on, we've been using this every unit. Yeah, Pythag. Fill it in for me. What goes what? I got x, 4, and 5 you need to put in there for me. Oh, 8. You want to fill that in?
X squared plus 4 squared equals 5 squared.
Having a good day there. Having a good day. And what's the value of x here? Hi, Callum, 8 again.
I got 3.
3, yep, 3 units. Reason, explanation, I don't want Pythag. What circle theorem did we just use here that helped us out? Think you got it, Via?
Yeah, so radius and perpendicular.
Okay, yay. Everyone here, Via said radius. That's fine. You can put diameter too. Either one's fine, diameter, radius. So a radius perpendicular to a chord. Want to keep talking here? What happens?
Bisects the chord.
Done. Yep, bisects the chord, and I'm done. Here you go. We didn't get to put it in our reasons last 2, but we can use it here. All right, who's on 4 here? Ooh, how do I find chord X? Nothing's being bisected here, right? Nothing's being bisected. What the heck do I do here? I didn't give you hardly anything, did I? Zach, got a thought?
Yeah, it's 90 and both sides are 6.
What? Whoa. Both sides?
Yeah.
I only have one side labeled 6. How do you get the other side 6? Keep talking.
Both radians are
Radians? What's the deal with you guys? They're not called radians. That's an angle measure. Radii. Thank you. Everyone, yes, this is a radius.
Yeah.
6. So any radius in this diagram will be 6. And once again, I can use Pythagorean theorem. Yes. 6 squared plus 6 squared equals x squared. Or I let you guys off easy here. Should have said simplest radical form above average students, but you get a break here. Nearest 10. Nearest 10 on the directions. What do we look at here? 8.5. What do we use here? Other than Pythag, the circle theorem we used here. Talk to me. What else did we use here other than Pythag? 12? In it, make sure, good, yes, and I'm going to be picky because when you just, I don't know, Ellie, just say it one more time, and I'm just going to pick on you here. It's not your fault, though. Okay, when you say that, you're saying every single radii known to man and woman are congruent. Is that true? No, that's why I need before in a circle. Okay, that's why it's so important. Hopefully, you guys understand now why I need in a circle first. All radii are congruent. Okay, all radii congruent. All right, one more here. And I get it with this one. It's very easy to look at it and just say, oh, x is 3, we're done. Well, how'd you get there? You're right, x equals, why don't we just, here you go. You're right, sure. You got it, x equals 3, but how did we get there? How did we get there? Anybody know anything about the chords? Anything you want to throw at me about the chords? Zach?
That their ratings, that they're bisected.
Okay, the chords are getting bisected, right? But here's my concern. What am I bisecting? Like what number am I or cutting in half, right? Am I cutting 10 in half, 12 in half? How do I know I'm cutting 6 in half in this case? All right, Molly? What do you mean? Okay, why are the chords? The chords are congruent. Because how far away are they from the center? How far is each chord away from the center? 7. And what did we just go over, Romeo? 2 chords?
That are equidistant from the center
Are
congruent.
there you go. All right, so theorem number 1. 2 chords equidistant from the center are congruent. There's theorem number 1. Thanks, Dwayne. Been waiting forever for those. Nice. That makes this chord 6, and everyone good? Why this chord is now 6 units long? Because of this theorem. Then, Zach, going back to you, I noticed they're perpendicular, so what's happening to that chord? It's getting bisected. Radius, what do you want to put here? Radius, diameter? Radius, sure. You can write the word diameter too. Radius, perpendicular to a chord, bisects the chord. That's how I get to 3. Okay? Questions? 10 minutes. Get it going. Get it going. Everyone get it going.